All right, so these are going to be the notes for 1.2, and you'll notice I have not changed because it's been 15 minutes since I finished the video for 1.1. You'll probably notice as I do this, I do them in bulk, so you'll notice I do 4 or 5 videos. I'm not changing, I don't care. All right, so measuring segments. When you're looking at the distance between any two segments, it's going to be written one of two ways. Either the length of AB or AB with a line over the top. And because we're a little jam-packed for space, I'm going to write it over here, all right, with a line on top. Now, if you notice, I don't have arrows on the ends, and that's because it's a line segment. And if you want, you can just get in the habit of making like dumbbells and putting points on each end so you know that it stops here and here. All right, so measuring segments, if I'm looking over here at AB, number 1, your measurement for a segment should always be a positive number because the last time I checked, I couldn't go a negative 4 miles. It's 4 miles in that direction. All right, so as I'm looking between A and B, I'm probably going to count. That's going to be my easiest. 1 line, 2 lines, 3 lines, 4 lines. All right, so that is 4 for length. Now, you'll notice there's no units, so that makes life a little difficult. All right, congruent segments is talking about whether or not you have two segments that are the exact same length. So, if AB equals CD, all right, and we're talking the actual measurements, then we're going to write it as AB is congruent to CD. All right. Now, obviously, equals and congruence is kind of a new definition. We've dealt with equals all through algebra, but congruence means same shape, same length, same everything. All right. Equal means 4 equals 4. Congruent is talking about shapes, angles, side lengths, all of that fun stuff. All right, now your segment addition postulate is one of your most popular postulates. And the reason for that is because I can do all of your algebra review in a unit for geometry, and we get to skip a couple days of algebra review. So the segment addition postulate says that if I have AB and I add it to BC, then I should get the entire length from A to C. So over here, little bit plus little bit equals the whole shebang. All right, logically makes total sense. In practice, a little weird to kind of get used to. Now, when it comes to writing it, here's kind of what I always recommend for students. Your common point should be in the center. All right, your end points for A and C should go on the outside edges. All right, so we're going to start doing a whole bunch of examples, and you'll notice I don't necessarily do all of the examples. I'll do probably 75% of them, pickups. And the reason for that is I want you guys to have some practice problems, but I also want to make sure that I'm not sitting here and lecturing for 45 minutes. You're like, dude, I get it. I can solve for X. We're fine. Let's move on. So, starting in with the examples, all right? For questions 1 and 2, we're using this picture right here. So for number 1, it says PQ is 9 and QR is 28. Find P to R. So that's the entire thing. It's literally as easy as you're thinking. All right? It is going to be 9 plus 28 equals, and in case you haven't done math in like the last 3 months, it's 37. All right? Now, on some of your homeworks, especially the ones where there's algebra involved, like the ones we're going to get to down here, box your final answer. All right? It is number 1, a good habit to be in, but number 2, let's say you finish, you've solved for X, but you haven't done exactly what I need you to do, then I can give you most of those points because you didn't take it that one step further. So you might get 4 out of 5 instead of 5 out of 5. All right. Number 2 says that QR, and I'm going to switch my colors, QR is 17, and PR, which is this whole thing right here, is 21. Now, you need to find what PQ is. All right, so I have some X plus 17 equals 21. All right, that makes life a little easier because you know, all right, I don't know what this is. This plus this equals the whole, and you can solve and get that X equals 4. Now, let's go down and do some of these example problems. I'm going to pick a couple that I think are going to kind of trip you up, because that's always what I wanted in notes was give me the ones that are going to confuse me. Don't give me the easy ones, because Lord knows we all get the homework. Sweet, I knew how to do this in class. And you get to it and it's all looks like calculus. That's not my goal. Your homework will directly match with your notes. Okay? So as you're going through, the order that your notes follows the exact same order on your homework. All right, so number 3 says, if EG is 71, find the value of X. So we're setting up and we're solving, and I'm actually going to blow this up so we can focus on one problem at a time. So here's 3. Huge. So let me get this out of the way real quick, so we can have some extra space. 71. So when you're setting this up, remember it's part plus part equals whole. So 8x minus 17 plus 5x minus 3 equals the whole thing. All right, and if that's something that you want to write on your homework, feel free. So that's just part plus part equals whole. Almost like that. Now, when it comes to solving for X, it's just like you did in algebra. I'm going to start by combining my like terms. So I've got an 8x and I've got a 5x. That gives me 13x. And then I've got negative 17 plus a negative 3, and that's negative 20. And that equals 71. Add 20 to both sides. And I have 13x equals 91. Remember correctly, I want to say that's like 7. But let's just double check, because I forget math too. And this is a perfect time for me to kind of tell you guys, don't feel bad for not being able to remember how to do basic arithmetic. Number 1, you guys all have calculators on your phones, so let's be honest. You're used to using them. Use them, seriously. And if your parents spent money buying you a nice fancy calculator, that thing should be your baby. I have had the same TI-83 since I was 14. That thing is older than all of you. It's still alive and kicking, although I did have 2 students who didn't mean to try and kill it, but they tried to kill it this past year. All right, so find the value of X, X equals 7. Always double check the actual question, because it'll say find the value of X. That's what tells you you're done or not. All right, since I've got it all nice and zoomed in, I'm actually going to scroll over here, and we're going to look at number 4. So 4 says TV, meaning from T all the way to V, is 14x minus 8. All right, now, the biggest thing I'm going to point out to you is it doesn't say solve for X anymore. Now it says find T. All right, you're still going to have to solve for X, but it's an additional step at the end where you have to plug in your value of X. So if we're doing what we did last time, it's part plus part equals whole. So part 1 is 9x plus 2. Part 2 would be 5. And this equals 14x minus 8. My poor computer is a little laggy because it's trying to upload your notes for part 1. Again, start with combining your like terms. All right, and then we've got some stuff we've got to move around. So I'm going to zoom it or roll it down a little. So I'm going to move my 9x. And then, because I'm a little lazy and I want to do things at the same time, I'm going to add 8 over here. So my 8's cancel. These 9's cancel. And I've got 15 equals 5x. So x is going to equal 3. Now remember, I pointed out at the beginning, it says find TU. You're not done. This is part of the issue with geometry. You guys just like to jump in, I'll solve for x, I'm done. That's not how geometry works. I'm really sorry. Geometry is very much tell me what I'm actually looking for. All right, so to find TU, TU is right here. So I have to take that x equals 3 and I need to plug it back in. I'm going to switch colors so you guys can see this work. So I've got 9 times 3 plus 2. And this is me trying to find TU. All right. So 9 times 3 is going to be 27. 27 plus 2 makes it 29. This is your actual final answer. All right. So let's zoom out real quick. And we'll kind of look at the bottom. Now, if you're looking at the bottom, you're back down to the exact same problems again. This is solve and find for JL. This one is plug it in, solve for X. It just got a little bit more complicated. Typically, when students start getting a little frustrated with these, is they don't know how to set them up. You guys can solve for X until the cows come home. It's knowing how to set them up. So, in the spirit of just setting them up, we'll set up 5 and 6, but I won't solve them unless you guys really need me to, and that's what those live Q&A sessions are for. So, on this one, I've got JL is 5x plus 2. Part, whole. Solve for X. Same type of dealio is going to happen over here on number 6. I've got whole for CE, that is 7x plus 4. Part plus part equals whole. Solve for X. So, in the sake of me not boring you to death, let's keep going. So, if we go to that back page, and I zoom it so we can actually see it, 7 is going to be one of your more complicated problems simply because I'm asking for multiple things at the same time. So if I zoom this in just a little bit, call it 150, all right, you're still solving the exact same problems. It's just now I'm telling you, okay, find X and then plug X back in for everything. All right, so they tell me SK is 13x minus 5, KY is 2x plus 9, and then the whole thing from S to Y is 36 minus X. Now, the one thing I want to point out as I'm doing this is if you notice, I doodle all over the picture. Because when you can see it on the actual paper, you tend to know a little bit more of what you need to do. When it shows up in words, that's more complicated. I need the visuals. So I like to do it just like this. So as we set this up to solve it, I've got 13x minus 5 plus 2x plus 9 equals 36 minus x. Combine my like terms, 15x plus 4 equals 36 minus x. I'm going to move the x over, and I'm going to move this 4, so it'll cancel, and that will cancel. And because I write way too stinking big for these pages, I've got 16x equals 32. So x equals 2. Ta-da. That's the bulk of the work. Everything else is just plugging stuff in. So I need to plug in x equals 2 here, here, and here. So 13 times 2 minus 5, 2 times 2 plus 9, and 36 minus 2. Then you just got to make sure you write them in the right spot. So for SK, 13 times 2 is 26. 26 minus 5 is going to be 21. 2 plus 2, or 2 times 2 is 4, which works out both ways. 4 plus 9 is 13. And 36 minus 2 is 34. I guess you really didn't have to do that one. You could have just added these two together. You would have gotten the same thing. But it kind of helps to see multiple ways. Now, this entire next section is going to be a lot of definitions. But, ooh, that's way too far out. Let's go page width. All right, but we're talking about the midpoint of a segment. Now, the midpoint of a segment is any point that's going to divide that segment into two congruent parts. And that is your midpoint. All right, a line or a ray or a segment that intersects a segment at its midpoint is called a bisector. All right, now a bisector is something that causes the segment to be cut in half. You'll notice in geometry we use a lot of words that mean the same thing. All right, so this is a segment bisector. All right, in the diagram to the left, what would be considered the midpoint? Now you'll notice there's two little notches here and here. Those two notches are telling you that AB is congruent to BC. Those symbols tell you that they are congruent. All right, so B is actually the midpoint of segment AC. All right, and line L right here is going to be our segment bisector. For AC. Examples. It's literally the same thing we've been doing. Except now, when you know it's a midpoint, you can say that these two are the same. All right, so if I know that those two are the same, they are congruent, it also means that they are equal to each other. So I can say 7x minus 16 equals 4x plus 2. As long as you know it tells you it's a midpoint or a bisector, you can make the leap that these two are congruent. All right. So normally I would ask you guys, do you want me to actually solve it or just set it up? Vast majority of the time people are like, I'm done. I got it. I'm going to set up 8, 9, and then I'll solve 10. So the people who do feel like they're done can move on. Everybody else can kind of hang out here for a minute so we can make sure we're all on the same page. So I'm going to zoom this in just a little bit. All right, so 9. H is the midpoint of GI. So that means congruent, congruent. Again, set equal, solve. 5x plus 2 equals 9x minus 10. Solve for x. All right, same thing on 10. R is the midpoint. They literally tell me. All right, QR and RS are the same. So I've got 2x plus 16 equals 5x minus 17. So to solve for x on these, it's the exact same way we've been doing it. I'm going to move this 2x over here. Cancel. And I'm going to move this 17 over to this side. that cancels, so I've got 33 equals 3x. Alright, divide both sides by 3, and I have x equals 11. Now the question is, am I done? No. Alright, not done. It doesn't say just solve for x. It says find QS. Now luckily, these two are the same. So do I really have to plug it in twice? The answer to that is no, I don't. I'm just going to plug it in on this side. So 2 times 11 plus 16. The reason I'm only going to plug it in on one side is because this is the same thing. Why do more work if I don't have to? So 2 times 11 is 22. 22 plus 16 is 38. All right, if this side is 38, then this side over here also needs to be 38, correct? So, to find QS, it's going to be these two added together. So it'll be 76. Watch that as well. All right. $11 gets a little tricky because it starts involving multiple variables. So I am going to work through this one completely as well. All right. So G is a midpoint. Start here. Ignore the rest of that for right now. Okay, the reason I want you to ignore it is because you've got multiple things you need to do. Start with what you know. All right, even if you're on a quiz or a test and you're like, dude, I don't know what to do with a y. Why are you throwing multiple variables at me? This is crap. All right, start with what you know. If these two are midpoints, then these two, if G is a midpoint, then these two segments are the same. They are congruent. If they're congruent, then I can set them equal to each other. All right, solve for x. Move the 12 over here, move the 4x over here. All right, so I'm going to add 12, and I get 15. And then I'm going to subtract 4, and I get 3x. So x equals 5. All right, now, FH equals this. Okay, I can find what FH equals as a number because I know what x is. So if x is 5, I can plug 5 in. So 4 times 5 plus 3. All right. So that means each of these, so FG equals GH equals 4 times 5 is 20 plus 3, that's 23. So, final step, this is also, well, let's fix this. So we're consistent. FH. So the whole thing is going to equal 46. So if FH equals 6y minus 2, I can also say that FH equals 46. So 46 equals 6y minus 2. Now I can solve for y. Add 2 to both sides. I have 48 equals 6y. Divide by 6. Y equals 8.